So this is the sample that I gave. We have for primal and dual. So the primal is to maximize the total profit, which is equal to 2x1 plus 4x2 plus 3x3, subject to the following constraints. So if you try to look at the second LP model, so included are the slack variables. So we added slack because the sign is less than or equal to. And this is the initial tableau with the replaced row and the optimal column and the new value of x2. This is the second tableau and the final tableau. So if you try to look at the final tableau, the decision will be to produce 6.67 of x2 and to produce 16.67 of x3 to get a profit of 76.67. So if you try to look at the value of your CJ minus the CJ of intersectional element of S1 and S2, that will be the value of your x1 and x2 in the dual, and the total cost will be the same thing. It's 76.67. So let's take a look. So this is the dual. Since it is greater than or equal to, we subtract slacks and add artificial. So this is the initial tableau, the replaced row, and the new value of x1, or in this case it's y1. So that's the second tableau. The third tableau and the fourth tableau. As mentioned, fourth tableau and the optimal tableau. So we have five tableau in the minimization. So as mentioned before, we already saw the value of your x1 in the primal, which is 5/6, and in the dual it's 2/2. And the same thing, the cost will be 230/3, or 76.67, the same as in dual. So if we try to look at the final tableau also, your S2, the intersectional element of CJ minus AJ and S2, is equal to 20/3, and for S3 is 50/3. So these are the value of your X2 and X3 in the primal tableau. So the total cost is 76.67, the same as the profit in the primal. So that's the relationship between the two. If you cannot be able to solve the problem in primal, you can do so in dual, and you'll get the answer of primal even if you don't compute it. So thank you.